Hi, hello, very good evening, one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. And warm welcome to the very innovative series, very useful series, Mastering Concepts for GATE 2023. Join the session quickly and mark your presence. I am Satya, waiting for you all to join the session. AB de Villiers, after a long time. Good evening. How are you doing, man? Quickly join the session, guys. Hi, Vishal. And those who have joined, please do like the session, share to the maximum possibility, and also please do subscribe to our channel. Those who have joined, let me know your presence. All right. Hi, Kirti ji. Good evening. Hi, user. Good evening. I hope you are all doing fine. So, today we are starting this computer network subject in this series, and the next 1 week we will be discussing some important concepts of this computer networks in the first cycle. So, as a part of which today we are going to discuss the basics, fundamentals of computer networks. If you need to understand any concept at the gate level, directly you cannot go to the concept. Directly you should not go to that concept and start reading, because that understanding would be partial. The base will not be strong, because when you go in that way and learn, you will not be able to solve all the questions, all model questions. So guys, always have patience to know the fundamentals or basics of any concept or any subject. That's why I am starting with this as my first class, that is fundamentals of computer networks. So quickly let us proceed. This is quick brief about me. I am Satya with 14 plus years of teaching experience, mentored more than 30,000 students, qualified in GATE, UGC NET, SET, also certified by Cisco. So guys, the one who are in the third year or final year, for you guys, we are doing a workshop. With this workshop, you will be getting the idea, getting the understanding about how you can secure All India rank 100 or under that in the upcoming GATE exam. This will be taken by our experts. So get the tips, get the suggestions from our experts and follow them with your hard work. Definitely you will be the winner in the GATE 2023. So join this session on 22nd May at 12:30 p.m. on our BYJU'S Exam Prep GATE channel. Don't miss this. Okay. So let us get into the things. First of all, when you say network, whether it is a computer network you say or any other network you say, what is basically a network? For a network, guys, three conditions must be satisfied. Whenever you have to say that it is a network, the network existence is there, what should be satisfied? Three conditions. What are they? A group of nodes connected and communicated with each other. So what are the three constraints to be satisfied for network? One is group. So there must be more than one. Whenever I say group, what does this mean? There should be more than one. And there should be connection. So when there are more than one node, they should be connected. And just because they are connected, you can't say network exists. Communication also should happen, right? So these three conditions when satisfies, there you can say the network exists, right? So here when I say computer network, what these nodes means, these nodes may be computers, these nodes may be networking devices also. They can be networking devices also. They can be computer means need not to be desktop, any form of computer, maybe desktop, maybe laptop, maybe remote, maybe mobile, any form of computer you can take. Okay, now when we talk about connection, what are different forms of connection? Ultimately, two forms of connection exist: wired, wireless. Wired medium connection, other term, technical term is what? Medium. Vishal, we will see. Switches, hubs, routers, gateways, NIC, they are all networking devices. So wired medium, you can also say as guided medium. Wireless medium, you can also say as unguided medium. So basically in the network, computer networks, two forms of connection will be there: wired, wireless. So wired means what? Cables. Physical connection. You can see the connection between the nodes. Wireless, which is logical, means which is invisible. So how they get connected? Through electromagnetic waves. Through electromagnetic waves, you may connect two or more nodes and communicate, or through physical connection or cable you may connect. So when you take cable, several forms of cables, if you just see around you also, you will find many types of cables, right? For mouse there will be a cable to connect, for keyboard there will be a cable to connect, for charger also you will have a cable. So can we use any form of cable? Means no, because we are supposed to transmit, communicate data here. So for the data communication, majorly three forms of cables are suitable. What are they? Twisted pair cable, coaxial cable, fiber optic or optical fiber cable. All types of cables you can't use for computer network communication, for data communication. Three forms of cables only are suitable to transmit data without attenuation, without distortion, without noise, means without losing the data. These three are majorly suitable out of all the existing cables. Of course, these also have their own pros and cons. In this, which is faster? Obviously, Optical fiber cable, you can say faster. Why? Why? Because this optical fiber cable transmit the data in the form of light. Means in the form of photons, the data gets transmitted. So we know the speed of light, 3 into 10 to the power 8 meters per second. So at the speed of light, the data gets transmitted. Hence, optical fiber cables will be fastest. Then coaxial cables, obviously, then twisted pair. Vishal, that depends on the we can say multiplexing. That depends on the multiplexing, means how we multiplex or partition the channel bandwidth accordingly, whether it is going to be serial or parallel transfer, depends. And we will see that mode of communication also. Okay, in this twisted pair, guys, we have two types of twisted pair: unshielded twisted pair, shielded twisted pair, UTP, STP. In coaxial cables, yeah, okay, in coaxial cables, if you see here, you are having a thick copper wire surrounded by so many layers. So because of this, noise will be prevented much. Means it will not be affected by the noise that is generated outside. But twisted pair cables are highly susceptible to noise, whereas coaxial cables are less susceptible to noise, and optical fiber cables are not susceptible to noise. Right? And accordingly, we have to use the connectors: RJ11 connector, RJ45 connector. RJ connector we use, registered jack connector we use for twisted pair cables. RG connector or T connector or terminator, we can use different forms of connectors with the coaxial cables. And fiber optic, yes, we have step index, graded index. In fiber optic, again, we have different ways. I mean, two types of fiber cables. We have step index, graded index. Okay, so all these three types of medium you can use for data communication. When I talk about wireless medium, as I said, electromagnetic waves are what? Wireless medium. We know electromagnetic wave spectrum, when you take, we have several ranges, several bandwidths, and based on the intensity of that, we call that particular wave with different name like radio wave, microwave, infrared, visible light, UV ray, gamma rays, X-rays, right? So all the types of waves are suitable for data communication here? No. We use these three types of waves: radio waves, microwaves, IR waves. These three are what suitable for our computer network communication. Obviously, as you can see this diagram, radio waves frequency is less compared with microwaves, compared with IR waves. So IR waves are high frequency waves, right? So where you use these radio waves, as you can see the images here, in FM radio, AM radio, in the television broadcasting, Bluetooth, Wi-Fi, all these use radio waves. And microwaves basically used for satellite communication. Other than the domestic microwave, other than the domestic application microwave, I can say where we use this microwaves in satellite communications, we can use these microwaves. That means our mobile communication is happening through microwaves. That's why, guys, when you are not using, please make your data connection off. Many people said many times. I am just taking this as opportunity to remind you again. When you are not using it, please keep your data connection off. Then it would be radio wave communication, normal mobile communication. When internet communication you are doing, that again involves microwaves. So they are high frequency waves. Excessive usage is not good for our health. Also, when you are sleeping, it became a very regular habit for today's generation. They keep their mobile just beside them, keeping the data connection on. That's not good, guys. That's not good for your health. So please remember, try to use the mobile phone wisely. Mobile phone is not bad. The usage should be proper. Okay, I am not here telling technology is bad or mobile is bad or microwaves are bad. The usage should be proper. It should be wise. Okay, please do understand the intention and try to use accordingly. And IR waves, infrared waves, where do you use? As you see, IR waves are majorly used for remote sensing applications. Remote sensing applications. Okay, so here IR waves are unidirectional waves, means at a time they can send signal or communicate only in one direction. Similarly, microwaves are also unidirectional waves. But radio waves are said to be omnidirectional waves, means in all directions or in multiple directions or in many directions they can transmit at a time. Yeah, Wi-Fi is okay, because till Wi-Fi router, it would be microwave communication. From Wi-Fi router to your mobile, that is a radio wave communication. That is okay. But I am talking about your mobile data. That try to keep off when you are not using. Okay. And radio waves does not require line of sight. They don't have this. Line of sight means transmitter and receiver should focus each other, or the receiver should be in the transmitter's range. Like that, radio wave doesn't require line of sight. But whereas microwave do require line of sight, and IR waves also require line of sight. That is the reason why TV and remote, they work only when you focus to it. Like if TV is let's say beside my wall, to the other side of the wall there is a TV, to this side I am here. Though it is a short range communication, even if I try to operate with my remote, it won't work, because it demands line of sight. Transmitter and receiver should be focusing each other. Focus means need not to be perpendicular or exactly 90 degree. there is a range, right? No, even we do require line of sight, guys. Like I am looking at somewhere and I am telling the things. You can't concentrate properly, right? Like when you take a teacher and student, teacher student also have this line of sight. They should focus each other. Like I should look at you, you should look at me. Then only proper communication take place, right? Simple. So the connection can be either wired or wireless. And communication, when you talk about, basically there are three modes of communication. What are they? Simplex, half duplex, full duplex. Full duplex, simply you can say duplex. In short, we call it as SX communication. This as HX communication, and this as DX communication. Okay. So what is a simplex? Unidirectional. If you take, there are two nodes A and B. A is always sending, B is always receiving. A can never receive, B can never send. For example, you take keyboard and processor. Keyboard being always sender, CPU is the receiver. So the communication between keyboard and CPU can't be reversed, right? Similarly, if you take CPU and output device like printer, like if you take CPU here as a sender, or and if you take monitor, or let's say printer, CPU will send signals to printer. From printer you can't get. I am not talking about all-in-one, only printer I am talking about. So it's a simplex communication. And what is a half duplex? A can send, also receive. B can send, also receive, but not simultaneously. Means while A is sending, it cannot receive, or while receiving, it cannot send. Okay? While sending, it can't receive. While receiving, it can't send. The best example for half duplex communication is Bluetooth. Bluetooth is half duplex. And what is full duplex? A and B can send and receive at the same time. Simultaneously, A can send while receiving. So the best example, you can say mobile communication or internet communication. So the communication can be either in the simplex mode or half duplex mode or full duplex mode, and somewhere you may find full duplex, that is A is able to send and receive, not to the same node. Here in the duplex, what it is, to whom A is sending, from the same A is receiving. But in full duplex, which is designated as FX, A will be sending to B, receiving from C at the same time. So sender is different, receiver is different, but happening simultaneously. So that is what full duplex we say, right? And when you are taking a group of nodes, there can be different arrangements possible, right? There can be different arrangements possible with these nodes, with this group. So that arrangement of nodes is what you say topology. So what are different topologies we have? Bus topology, ring topology, star topology, mesh topology, tree topology, or two or more combining, that is a hybrid topology. So in bus topology, if you see, a single cable is used to connect all the nodes. Single cable is used, right? So when there is a single cable, all should share this single cable. Can we expect privacy or security in this bus topology? No. So we cannot expect. Of course, we are deriving different measures to reach this, but the topology does not offer this privacy or security, isn't it? And are we using any intermediate networking device here? No, it is a direct connection. And is it point to point or multi-point? Means the cable is shared between only two nodes or multiple? Multiple. So you can say bus topology is following multi-point configuration. Right? Now, every cable is connected, every node is connected how many with how many IO ports? Single. So there is one IO port per node. But if you take a ring topology, every node is having two IO ports, right? So every node is connected to two other nodes here. And every cable, if you see, to how many nodes this cable is connected to? Only two. Like A and B are connected with this, B and C are connected with this, C and D are connected with this, and so on. So every cable is dedicated to only two nodes. So you can say this is point to point configuration. Right? And here, what about privacy or security? If any two direct or immediate neighbors are communicating, there is privacy. If A wants to communicate to D, if A wants to communicate to D, definitely it should pass the data through B and C only. So here you can say there is very less privacy or security, or partially it is offered. And this ring topology supports unidirectional traffic. Means how you configure it. In that way only it always communicate. So ring topology supports unidirectional traffic, either in clockwise or anti-clockwise. And star topology. Here we use a central controller. Generally, mostly used is what? Hub. Hub stands for Hybrid Universal Broadcasting Device. Hybrid Universal Broadcast. So broadcast means what? One to all. It take from one and send to all. So as you are using hub here, because of hub there is no privacy or security, because you are supposed to send to only particular node, but hub broadcast it sent to all, right? And if we have n nodes here, how many cables we are using? See, we are using n cables, right? If we have n nodes, we are using n cables, and every node is connected with how many ports? Single IO port. So there is one IO port per node. In ring topology, how many cables are required if we have n nodes? N cables. You can count. In the given example, there are 6 nodes. Yes, we have 6 cables. Right? And if you take mesh topology, you can see the mesh topology. One is connected with every other node. Like this, it is called fully connected mesh or completely connected mesh. If it is not connected to all, only to few, then we say it is partially connected mesh. So ideal case, I am taking the completely connected mesh. So if we have n nodes, how many IO ports will be there? N minus 1 IO ports will be there. And every node is connected with every other node, right? So between every 2 nodes there is a direct cable. So how many cables will be there? N into n minus 1 by 2 cables will be there. And does it use point to point or multi-point connection? Obviously, every cable is dedicated to only 2 nodes. So point to point. And does it offer security, privacy? Definitely yes, because between every 2 nodes, we have a dedicated cable. So definitely we can expect privacy or security. But it is generally not used in the regular networks because of cabling cost. Management is very difficult. Here if you take just 6 nodes, 6 into 6 minus 1 by 2, that is 30 by 2, 15 cables for 6 nodes. Just imagine if I have 500 nodes, you would require somewhere around 10,000 plus cables. So the management becomes very difficult. And of course, cost is also high. Right? Here, and we have the other topology, that is a tree topology. Tree topology also use networking devices. They are hubs, but here we use multiple hubs. Single hub is used in star topology. Multiple hubs are used in tree topology. In this, there will be 2 types: active hub, passive hub. Minimum 1 active hub is used in the tree topology, that is as root. What is active hub? Hub with repeater functionality is what you say active hub. And the other secondary controllers. Active hub is the primary controller, that is root controller. The other controllers may be active hubs or passive hubs based on the requirement. Right? So hierarchy when we require, then we prefer this tree topology. Vishal, you are only looking about physical connections. You think in terms of communication. Then same topologies will be applicable even for wireless medium also. Like your A, B, C, if you take here in the ring topology, B is connected to A as well as C wireless. So B is at a time connected to 2, not connected to E, F and D. So 2 IO ports are there. So you can say that is a ring topology. Means It is not physical arrangement. That's why I did not mention it as physical. Whether it is a physical arrangement or logical arrangement, means how they are connected physically matters, how they are communicating also matters. Both should be taking into consideration. Okay, so today in computer networks, wherever you go, like in small scale industries, software industries, majorly what topology, sir, means, you can say hybrid topology, because they want different features from different topologies. So majorly you find hybrid topology. In college computer labs, what topology you find? I think mostly star topology. They'll use one central controller. They may use it as a hub, even they may use it as a switch also. Mostly switch is used today. So star topology you will find in majority of computer labs. And in defense organization kind, in the very prestigious organizations, or where we require high confidentiality or security, there you may prefer mesh topology. Okay, Vishal, it's called hierarchical topology. Like we will have active controller hub. To that, what nodes should directly communicate, we will connect. Other nodes like this in the form of tree, like this is a hub, this is another hub, this is another hub. Let's say I am taking 8 port hub. So two are connected to other hubs, secondary controllers. These are nodes, computers. That means these 6 can directly send or receive the data, but the other, if they need to send, definitely it should pass through the primary controller only. Like in the software industries, you see the teams, right? Like this, when you are expecting a hierarchy, this tree topology is preferred, because with the controllers, with the hubs, you can actually monitor the communication. So, okay. Then in the part of fundamentals, definitely you have to know about this standard OSI model, which is given by ISO, International Standards Organization, has given this OSI. What this OSI says is, if any two nodes are communicating, whether it is through wire or wireless, irrespective of the medium, the data should not directly enter into the medium and go. Then you can't expect privacy, you can't expect security, right? You cannot expect on-time delivery, you can't expect error-free delivery. So if you want all these effective communication, then what OSI standard suggests, the data from the computer should pass through 7 phases, then only it should be entering into the medium. Similarly, once it reaches the receiver side, then the data should not be accepted or processed immediately by the receiving node. Again, it should pass through 7 phases, then only the receiving node should be processing it or accepting it. So these 7 phases, in the OSI terminology we say layers. What are they? Layer 7 being application, 6 presentation, 5 session, 4 transport, 3 network, 2 data link, and 1 physical. Layer numbering will be same, but only the order is what, like stack. Here first, from which layer the data is coming in the receiving end, that layer will be the last. So only the order gets reversed at the sender and receiver side. So what these layers has to do, every layer has its own functionality or set of functionalities to perform, guys. Like application layer provide you the application, the Word you take, Notepad you take, PDF you take, anything you are opening through which you are entering the data or receiving, opening what you received, that is what application. That is what application layer. Like browser, you want to check your email, you will open browser, right? Or in the mobile you open that mail app. App means what? Application. Similarly, you want to send an email, definitely through application only. If there is no application, how you can send or receive? So how you can form the data or how you can see the data? So application layer job is to provide an interface for user to send or receive. And then presentation layer deals with syntax, semantics, means it will check whether it is in the proper order or not, meaningful or not. Compression, required translation it do, encryption it do. Similarly, session layer, it is what logically partitioning the data, means by assigning the timestamps. Transport layer, this is what responsible for end-to-end delivery. From transport layer onwards, physical partitioning starts. Network layer, this is responsible between the networks, source network to destination network delivery. This is what responsible for routing, network layer. This is what responsible for IP addressing, which is the very important topic. Data link layer, where framing happens, where error control happens, access control happens, and node to node delivery, you can say, that happens at data link layer. Physical layer, which is directly communicating with the medium, whether it is wired or wireless. So physical layer is responsible for encoding, decoding, converting the data into bits, or bits into again the signal form. We call it as encoding, decoding, right? And whatever the medium demands are there, providing the connectors, like twisted pair demands RJ connector, coaxial demands RG connector, like that. Fiber optic cable demands SC connector or ST connector, accordingly dealing with the medium. Like this, every layer has its own functionalities to perform. So like this, when the data gets passed through, definitely efficient communication can be expected. That is what OSI suggests. But this is all theory, guys. For this to implement practically, protocols are required. That is what the drawback we find in OSI, lack of protocols. That's why we have got an alternate standard, that is a TCP IP, which is given by this IETF, Internet Engineering Task Force. What these people have done, they have kept the functionalities constant, but a small modification they have done. Application, presentation, session layers they made into only one layer now, that is application. Transport being the same, network being the same, physical and data link layers merged to one, that is as network interface. Vishal, presentation layer will do encryption, decryption, compression, and syntax semantics, means checking for the meaning and order. But session layer will be assigning the timestamps. It decide this much data can be delivered in how much time or can be transmitted in how much time. So in how many attempts this much data should be delivered. We say it as a token management. right? Where TCP/IP succeeded, almost the functionalities layering remaining almost similar. But why TCP/IP is used today? Today internet is based on TCP/IP because they have provided the set of protocols. So TCP/IP protocol suite you can see here. To implement what application presentation session layers to do, we have protocols HTTP, FTP, Telnet, so on. For transport layer functionalities to implement, we have TCP, UDP. For network layer, we have this. Like this, every layer functionalities to implement, there is hardware along with that software. Here, which is a hardware form of layer, which is software, or which is mixed, means application layer is completely software form. Completely software form. Transport layer, network layer are in the mixed form, means some hardware device along with some software will do what they are supposed to do. Physical layer is completely hardware, guys. Data link layer, again I can say hardware and software together. So what is the hardware we use? Networking devices. These are what different hardware we use. What are different networking devices you see? NIC card, hub, repeaters, switches, bridge, routers, even we have gateways also. NIC card is what you can say physical layer device. Physical layer device. Repeater is also we can say physical layer device. Routing happens at which layer? Network layer device. Bridge, data link layer device. Hub, data link layer device. Means what these layers are supposed to do, they are done by these devices with proper software support. Switch, data link layer device. Like this, we have router, which is a transport layer device. We have gateway, which is applicable at all the layers. Right. So please go through these networking devices and their functionalities first. Okay. So these are what different fundamentals which you are supposed to know, learn before you get into any topic of the syllabus, guys. I hope it is clear for you. I made it brief. So you everybody go through all these what I have discussed now, and if you need to connect with me, here is the way. Join my Telegram group for any guidance, PDFs, doubts clearance and everything. Okay. Thank you guys. Thank you so much for joining. Tomorrow we will discuss another topic. Till then, have a great time. Keep watching, keep attending all the sessions. Do like the session, share with all the friends, and subscribe to our BYJU'S Exam Prep channel. Okay. See you tomorrow with another concept. Attend regularly, guys. Take care. Good night, everyone. Bye-bye.